Welcome to 5.2, some operations with radicals. And we started pretty easy with multiplication. If A and B are real numbers, we don't have any imaginary, and they have the same root, when you multiply, then they just become the same thing. So square root of 9 times square root of 16. Well, square root of 9 is 3, square root of 16 is 4, 3 times 4 is 12. Or what they're saying is, well, because they're both square root, you could do 9 times 16 and get 144, then square root from there. Because maybe, perhaps, 9 doesn't square root evenly and 16 doesn't square root evenly. So like down here, cube root of 4 times cube root of 128. Well, this is saying we could do 4 times 128, get 512, cube root 512, and get 8. And that's what we did with all of these. They're fairly self-explanatory. Remember, we kind of talked last time, if it's an odd root, the negative actually comes out to be a negative. If it's an even root, negative comes out to be I. But yeah, we can multiply them together, provided they have the same root. If they don't have the same root, I'm going to show you how to fix that here in a minute. But we did a couple more. This one pieced everything together, and then, well, this is just kind of like, the last couple videos we did, where we just factor that out. How many chunks of 3 can I get from 5? How many chunks of 3 can I get from 7? And again, you got to be careful with this right here, because if they were all the same color, here, I'm going to show you. If these were all the same color, then it looks kind of confusing, especially the closer and closer these get. And so you got to be careful. You got to be careful how you write your answers on these. Dividing, let's call them fractions. Fractions, basically we can, as long as they're the same root, we can piece them together and make one fraction, and obviously go the other direction. But we cannot leave a radical in the denominator. We cannot have a fraction left inside. So here's how we do it. Did a couple of these. First of all, this one you can piece together as one fraction, then divide, then get your answer, because that fraction just reduces to 9. This one here, on this one, when you piece everything together, 12 divided by 3 is 4, and subtracting exponents here. Do I have it? Sure do. Subtracting exponents, this kind of goes back to an algebra 1 concept, but why do we subtract? Well, it's technically because stuff's canceling out, and 2 subtract from 3 gives me 1 left. 3 subtracted from 5 gives me 2 left. That's because 3 of them canceled, and that's what happens. That's why down here we did 4 subtract 1 and got 3. Well, the square root of 4 is 2, and I can get a single x from, or a single pair of x's, because that's x times x times x. Pair comes out here, and that's going to stay inside. Oh, okay, I did it this way. I did this one here and pieced it together. The fraction just became one big thing. 162 over 3 became 54. So we factored out 54. And since we're doing cube root, found a group of 3 3's. My 3 x's come out to be x, and my 2 stays left over. Then we went, did I not do more? Did I not do those down there? No, because we need to talk about how to fix these in the next video. I think we may have done this one. This one wasn't too bad. Here, hold on. There you go. Maybe if you're like, oh, I think I could do that one. Piece it together, becomes -8. Cube root of -8 is -2 times -2 times -2. So yeah, I'll show you how to work on the rest of them. If you want to kind of pause and write these down, we're going to have these in the next video. You want to see how far you get.